Hello out there, welcome back once again. I hope you're ready and you have some energy to keep going. And remember one thing, to do well in this mathematics thing is to work consistency. It's not about doing lots and lots of hours on weekend, once in the blue moon. What is important is better to do 20 minutes every day than doing 5 hours on weekend. And we don't work hard because we have a test coming or a class test or exam. We work even though we're not writing an assessment. Consistency is the key to do better. That's the most powerful thing. And you don't observe, we just look at. You need a pen and paper to try some of the problem, to think with me. Think a little bit. Write notes down. Okay, try a problem. Have a calculator in front of you. Okay, that's how we get better. So now, we're still on data analysis. We looked at the pie chart, and there was a question which asked us how many students preferred salted chips, something like that. Now we're going to look at another data analysis. How can we analyze that and arrive at some conclusion? So on the data, we're comparing set of data, pie chart, we'll look at that. Line graph, we'll still look at that. And box plots and bar graphs. Now let's look at comparing data set. Comparing data set. So the distribution of set of data described how the data is spread out. How the data is spread out. Do you have more of the data above the mean or below the mean, below the median, and so on. Okay. So two distributions can be compared by using one of the three average. So, and the range also. So example of comparing set of data, let's look at it. The number of cars sold by 2 salesmen. Each day of the week is shown below. So what you have Matt and Jamie. So they work for a dealership, they sell car. Jamie sold 5 cars on day 1. Day 2 he sold 7 cars. And day 3, 6 cars, 5, 7, 8, and 6. And Jamie went 3 cars, 6, 4, 8, 12, 9, and 8. By looking at the data, who is a better salesman? By looking at this, I can't even arrive to a conclusion. I can see that Jamie sold 3 cars, Matt went 7, 5 on day 1. Can I conclude based on that and say, yeah, on day 1, Jamie, you sold 3, Matt 5. But also, if you look at day 7, Jamie performed better than Matt by the same number of cars. Does that make sense? Because on day 1, Matt is better, Jamie 3, but on the last day, Jamie is better by the same amount of cars. What do you want to conclude? And also, if you look in the middle, there was Jamie better on day 5 sold 12 cars, where Matt 7 cars. A deviation by 5. Actually, this is the highest deviation we can see, which is 5 on the day. Can I conclude based on that and say, Jamie, he's a better salesman by using one day data? Can I? No, definitely. I cannot use one set of data and arrive to conclusion, no, Jamie is a better salesman. What can we do here? Is the average better? Is the minimum and maximum better? Let's see what we can do. Who's a better salesman? What do you think? You calculate the average? The highest average is a better salesman? Do you calculate the range? Do you do whisker plots? What do you do with the data? That's the most important thing. We're doing the analysis here. We're thinking about the data and we want to arrive at some conclusion. Okay. So who's a better salesman? Let's look at that. So we have the table there for all the cars. Remember, these are the sales of the car each day. To decide which salesman is best, let's compare the mean cars sold each day. So let's calculate the average. The mean is the average. Do you think the highest average is a better salesman? Do you think that? Let's see both means. So the mean format, remember how we calculate the mean? To calculate the mean, we have how many days here? We have day 1, day 2, day 3, day 4, day 5, day 6, day 7. Okay. So to calculate the mean, we have to add how many cars they sold. Agreed? Divided by 7. Because they were working for 7 days. Are we all together? So the mean for Matt will be 5, because day 1 he sold 5 cars. Day 2, 7 cars, so it's 5 plus 7 plus 6 plus 5 plus 7. He sold 7 cars, 8 cars, and 6. Divided by 7 because it was working for 7 days. Are we all together? Then put this on your calculator, which is 44 over 7, which is about 6.3 to 1 decimal place, if you round to 1 decimal. Okay. So the average, what does 6.3 mean? This means on average, Matt will sell, so we don't have 6.3 cars. Okay, we don't have 6.3. We have cars are 1, 2, or 3, 5 cars. There's nothing like that. There's no 6.3 cars. So on average, meaning he will sell 6.3 cars. He will sell about 6 cars. Less than 6 or more than 6, but I don't think more than 7 cars. On average, that's what will Matt perform at this company. What about Jamie? Let's look at Jamie. Jamie, we're going to do the same thing. We calculate the mean for Jamie. So this is the mean for Matt. The mean, we're going to take how many cars Jamie sold, divide by the number of days, which is 7. So let's take the mean for Jamie. The mean for Jamie will be 3, which is 3 plus 6, plus 6 and 4, plus 8, plus 12, because it sold 12 cars on day 5. Day 6 sold 9 cars and sold 8 cars divided by 7. Okay. Then we add that, we divide it by 7. We divide by 7. Then we get 50 over 7, which is 7.1, if we round to 1 decimal place. So the mean for Jamie is 7.1. And the mean for Matt is 6.3. Who is a better salesman? Who's a better salesman? So if we have both means there, can we conclude anything? This means on average, Jamie will sell 7 cars. Matt will sell about 6 cars. Daily average. It could be less. That's another thing average means. Okay? So on average, if we use average, Jamie is a better salesman based on average. Are we all together? But are you going to use average? Is average good for you, for your organization, for your business? Is something you'll consider? Okay. Or do you want consistency? It's okay that I sell 3 cars, 3 cars, 3 cars, 3 cars, 5. Or do you want me to sell 1 car, then 10? Oh, is that good? Is that what you want? I don't work hard on day one, but I work hard some days. Or do you want consistency? That will differ from one organization to the other. But based on average here, Jamie is a better salesman. So this tells us that on average, Jamie sold more cars each day than Matt. That's the meaning of this. Just on average. Okay. So that's one measure we used. So can we look at something else? Okay. There's no mode for both. Okay, if you look at Matt, mode, it's like 5. You know, does it tell anything? Under Jamie, there's no mode, you know. No frequent number that occur the most. So I don't think we can make any analysis from that. Okay. So what are you going to look at now? Still the same problem. The number of cars sold by 2 salesmen each day for a week is shown below. So still the same problem. We have Matt and Jamie. Still the same car. We're going to look at another analysis. The first analysis, we look at calculate the mean. And we said, what do we arrive? We said, based on mean, I think Jamie was better with 7.5, 7.1 average. But now, same question. Can you approach it differently and not look at the mean? Is that possible? I think it's possible. Because mean is not the only measure we can focus on. Okay. So let's do the range for each salesman and see. What does the range tell us? I think a range will tell us who's the most consistent. But is consistency better for you, or do you prefer average? What would you go with? Average or range? Okay, let's see that. And we said mode doesn't really tell us here. Okay. So if we do the range, just remember that the range is the maximum minus the minimum. So range is the max minus minimum. So it's the maximum minus the minimum. And remember, maximum is the highest value, and the minimum is the lowest value. Okay, that's how we calculate range. So if you look at Matt, what is the range for Matt? What is the Matt highest value? Matt highest value was 8. That's the highest numbers of cars he sold. And what about the lowest? The lowest is 5. That's for Matt. So Matt range is 8 minus 5, which is equals to 3. Are we together? That's the range for Matt. The highest minus the lowest, we get 3. What about the range for Jamie? What will that tell us? Okay. So let's look at the range for Jamie. And we know that the range also is still the maximum minus the minimum. Okay. So the maximum for Jamie is 2, the highest numbers of sales per day, and the minimum is 3. So this will be 12 minus 3. So 12 minus 3, which gives us 9. Okay? Matt range is 3. Jamie, 9. What can we deduce just looking at that? What can we analyze and arrive? Matt has the smallest range, Jamie the highest. This tells us that Matt is more consistent. He's more consistent. He will sell those 6 cars per day. If he will say he'll sell 5, He will sell 5. Consistency. And when Jamie is not consistent, there's like a huge deviation per day in how many cars he sells. Okay? Do you want consistency? Or do you want someone who sells lots of cars tomorrow and nothing the following day? All depends. Or do you want average? Okay. So the range of the numbers of cars sold each day is smaller format. That's what we said. This means that he is more consistent or reliable salesman. He's a reliable salesman. That's what we conclude by using their range. Okay? So are you going to go with the range or the mean? Okay. So this is what we have. Matt, mean 6.3. Okay, and range 3. Jamie mean 7.1. Range 9. On average, Jamie better. But on range, Matt better. And where do we go from there? I think, for me, I'll go with reliability. The average, very close together. I mean, 6 and 7. It's 6 and 7. The other guy will sell 6 cars. The other guy will sell 6. But the other one is even consistent. What do you think? The deviation on average is 1, but the other one is reliable. So I'll go with reliability and the 6. It will all depend. Okay, but that sounds better. So the better salesman, I would say, it's Matt. Okay, that's what we can. So we could argue that Jamie is a better salesman because he sells more on average. We could also argue that Matt is better because he's more reliable and consistent. Then, from there, what do? Is average or consistent? It will depend based on what you want, you value, average or reliability. Okay, guys, I hope to see you after this break. What are you going to do? We're going to look at another problem where we really analyze the problem deeper and see what is happening and arrive to some conclusion. Have we arrived at a conclusion here? Did we say Matt or Jamie? All depends. You can have different analysts with same data arriving at different conclusions. You can have a bank which predict the rent differently from another bank, which is possible. But what is important is to interrogate the data. See you after the break.